All right, let me pass around and sign in.
Wow, to get my head wrapped around that
All right, well, welcome to week 3. So we're like 1/5 the way through. This is like a really fast quarter.
Fast year.
Fast year, yeah, totally. All right, so any questions or comments up front? Yeah.
So I'm building an object in a constructor,
Mm-hmm.
and I want to pass the object I'm constructing while I'm constructing it as an argument. So I pass another method with this as the argument in the constructor. Does that destroy everything?
No, but I don't think this means what you think it means at that point.
It means the current object being constructed, right?
Yeah, no, it means whatever object you're sitting in.
Which would be the one that you're building.
So if you're like in a main method, right?
Yeah. Well, I'm in a main method. Nothing. There's no object of any type of this data type exists yet. It hasn't been built. And so you give it an argument, and it takes that and goes with the constructor.
Right.
Assigns all the data fields for the very first object of that data type.
Mm-hmm.
And then before it's done constructing it, it passes that, or it passes this as an argument to another method.
Yeah, that's fine.
And it'll take the, like, for example, if it's a word and a pointer, and then I want something else to interact with that word and pointer value as the starting off point.
Yeah.
I pass this to it.
As long as the method that you're calling is expecting an object of whatever type object you currently have, yeah, that should work fine. And it doesn't necessarily get you into an infinite loop either. Depends what you do with it down the road.
If I keep, like, if that constructor starts being recursive and going deeper into levels of the construction, and I continue to do that, will it continue to be consistent with what I think is happening?
Depends what you think is happening.
So, like,
So yeah, let's look at this in code.
okay.
Because I digested some of what you had sent over the weekend, but it may be going deeper than I think.
It's like getting closer to complete. It's not usable, but it's like being built.
Okay.
It goes to reality.
Yeah, let's take a look at it on the whiteboard and see if it's actually going down the rabbit hole forever, or if it has a way back up. Other questions, comments? All right, so I want to talk about some logistical, administrative things. I want to run through PA1. I want to run through some more PA2 stuff, and then we're going to start talking about statics. And we'll start using the dreaded static keyword, and we're going to move towards looking at class extensions. And by tomorrow or Wednesday, we're going to start playing with IntelliJ and start looking at how we can do some graphical stuff. PA3 is going to involve using graphics and making GUIs, things with buttons, and doing some drawing and stuff like that. So this will be a next level of using some of these Java classes. So first thing, I've posted a quiz on Canvas. I think it's due in a week or something like that, but it's, I think, 6 short answer questions, multiple choice. And you can take it unlimited times and it'll keep the highest score, so do that sooner rather than later. It's just an example of some of the kinds of things you'll see in like short answer sections on tests. The other quizzes I may actually turn into like take-home quizzes because they involve like scribbling some code, and I don't know if I want to get you doing that through Canvas. So you may see you know, a weekly take-home quiz, kind of like a homework, except you got to work on it by yourself. But we'll look at those starting next week. So a piece of homework for you to do is to download IntelliJ. So IntelliJ is an integrated development environment that we're going to use for PA3 and for some other stuff. And it's the idea of having an editor and a compiler and a syntax checker and something for filling in code and all of this inside one environment. So what you want to do in the next day preferably is go ahead and Google IntelliJ download, and you should get to something from jetbrains.com. Okay, that's the company that makes this. Click on that, there's just a download link. Go for the free download unless you like paying money. The community download is free. The ultimate one is a subscription based, I believe. We don't need anything that the community doesn't have, so just click on that and follow through the instructions. You need to register or something, but they don't spam you, or they haven't spammed me. So download that and install it, and make sure that it at least starts up on whatever equipment you're running. This software is available on the PCs in the Collaboratorium, and it runs there. It runs fine for me under Linux. It should run fine under Windows. I don't know about OS X. So whatever your environment is, download this and try running it sooner rather than later.
It works on OS X.
Say again?
It works.
It works fine? Okay, cool. All right, any questions on that? So we'll start talking about IntelliJ either tomorrow or Wednesday, so you want to have something so you can play along at home. All right, so PA1. PA1 is graded. I posted grades over the weekend, and really good job on PA1. The majority of people got 100%, which is great, right? Ideally, when you're doing the PAs, we've covered everything that you need to be able to do a perfect job on these. So getting 100% is not unreasonable. So a few things that I saw. So the reduction to simplest form was probably the biggest technical detail, and we'll look at some code shortly for doing that. But you know, that's dotting the I's and crossing the T's basically. It's getting everything nailed just fine. If you run out of time or something, then that may not happen. Second most common issue was issues usually with toString, and it was really a question of following the spec. If you have a fraction, you're trying to convert it to a string, there's certain things you've got to do, and we'll look at that in code also. But you know, if it's something over 1, you just print out the something. If it's got a denominator of 0, you just print out NaN regardless, or you return NaN. So details like that. The commenting's looking really good. So again, most programs that I looked at, the commenting was excellent. Nice block in the top saying who you are, what this is, when you did it, and so on. And then lots of comments on the lines of code themselves. That's what you want to see. If you lost a few points for weaker commenting, it was usually because, for example, in the reduce function, you might have 10 lines of Java code. You're doing modulus, you're using temporary variables, you've got a while loop, you're doing some negations and some ifs, and sometimes there were no comments anywhere in all of that code. Now, if you've been working on this, it's obvious to you why you're saying, you know, if d is less than 0, then n equals minus n, right? But if you've never seen this code before, take a look at what you've written and say, is it obvious from just glancing at this really quickly, is it totally clear what's going on here, right? If the line is something like number of tries equals number of tries plus 1, that's pretty obvious, right? There's something going on that I'm counting the number of tries and I'm incrementing it. But if you've got more than like 1 or 2 simple lines of code, you probably need a comment in there. So keep working on that, keep thinking about it. I have yet to see a case where I would say, you know, this is too much commenting. Okay, it's usually erring on the side of not enough. But play around with it, modulate it, and you know, after these things are turned in, if you want, if you and a friend both lost some points for commenting, take a look at each other's code then, right? This is after it's turned in, and say, you know, do you understand everything I'm doing here, or where would more comments help you, right? Or bring it to me and I can give you more specifics. So that's probably the only other thing that I saw. Make sure you follow the spec for turning it in, right? So uppercase fraction.java inside pa1.tar and so on. That's going up to being worth 10 points now for PA2. Documentation is 10 and then functional behavior is 80. So, and I updated PA2 to mention those. All right, so let's run through a quick look at some fraction code. So this is my version of the fraction class. So I header block at the top to get my points. So I threw some comments here because these are the only 2 class variables I have in the entire class, num and denom. And so I thought it was worth like describing what these things are, because this is where everything happens, right? That's all that I know about a fraction. So I use this to sort of spell out the special handling that happens. For example, the denominator is never negative, and I really, really rely on that. For example, when I convert to a string, I don't have to check to see if the denominator is negative and move it, right? I know the denominator is never less than 0. If the denominator is 0, the number is undefined, and I automatically set the numerator to 1. So my undefines always look like 1 over 0. If there's a 0 on top and it's not 0 on the bottom, I change the denominator to 1. So that my 0 is always stored as 0 over 1. Just conventions. I don't think I even use all of those, but I like to know in any case what I'm going to see when I look inside these variables. All right, so here's the constructor. And the constructor does a fair amount of stuff. So I set the numerator and denominator equal to the arguments. That's the first order of storing this fraction. And then I check to see if the denominator is negative. And if it is, I negate both numerator and denominator. And a lot of people's code, I saw this was interesting to me. They had code that said, if the numerator is bigger than 0 and the denominator is less than 0, then flip the sign on both of those. And then the next statement said, if the numerator is less than 0 and the denominator is less than 0, flip the sign on both of those, right? And you know that one of those is going to happen. And so it could have been written as just if the denominator is less than 0, flip the sign. But sometimes when you're thinking through these things, the code becomes a reflection of your thought process, right? Which I always like. And I usually leave that kind of stuff in my code unless, I'm turning it in for work or something. Because to me, that's going to be more logical when I go back and read it. So that was cool for me to see. Okay, so I take care of the negative denominators right there. From that point forward, denominator is never negative. All right, if the denominator is 0, I set the numerator to 0. I should have set it to 1, but right, save it as an undefined and just return. If the numerator is 0, I'm going to save it as 0 over 1, so I set the denominator to 1 and return. Otherwise, if I get down here, I know I don't have any of these special cases. I call reduce. And reduce is a method that adjusts those two class variables, num and denom, so that the resulting fraction is in simplest form. And then I'm done with my constructor. Now constructing from a single argument, a whole lot easier, right? No way it can be undefined. No way the denominator can be 0. No way the denominator can be negative. So here I just set the numerator to n, denominator to 1, and we're done. I could also have called the constructor with n comma 1 and punted to that. All right, two-string method. So this is how you're outputting your strings. You're converting it to strings. So two cases here. If the denominator is 0, we're going to do this anytime we touch one of our fractions, see if the denominator is 0. If it is, our fraction's undefined, I return nan. Otherwise, I want to return the numerator. And then if the denominator is 1, add nothing to it. Otherwise, add a slash followed by the denominator. So that makes a string that looks like a fraction, where if the numerator is 1, we don't see over 1. Okay, a couple of not very interesting accessors just for reading the numerator and denominator. And then Euclid's algorithm. So Euclid's algorithm is check to see if the denominator is 0. And if it is, again, it's not a number, so we're not going to do anything. Otherwise, I use this GCD function to find the greatest common divisor. That's what I call factor. And then I divide numerator and denominator by that factor. So that's elementary school finding simplest forms, right? Once you know the greatest common divisor. All right, so I wrote a separate method for finding the GCD. If one of the numbers you're using is 0, I just return the other number. That's an edge case. I don't think it ever actually gets called. But if you wanted this as a general GCD function, if you find the GCD of some number a and 0, it's just going to be a, because a divides 0. So if b equals 0, return a. If a is less than 0, then I flip it around. And if b is less than 0, I flip it around. So what am I doing? I'm taking the absolute value of a and b. Why? Because the GCD of -6, -2, or -6, 2, or 6, -2 is the same as the GCD of 6 and 2. right? It's just going to be 2. We're just looking for something to divide the top and bottom by. So I work with positives. And then we have the famous crooked arrow thing. So this is the thing that we do in 215 every time that we do GCD. We write down your first number as something times your second plus a remainder. And then we just shift these things over. This second thing becomes the first number, and the remainder becomes the second number. And we write the first number, something times the second plus a remainder, and then we shift that b over and that remainder. We keep doing that thing, right? Everybody remember that? Okay, cool. So that's what we're doing in code. Start off, we've got a and b, that's the arguments to our method. The remainder is a modulo b. And then as long as it's not 0, we do the shifting. We set a equal to b equal to remainder. And then we find the remainder of that new a and b, and we keep doing that until the remainder is equal to 0. And at that point, this is our GCD, so we return b. Now you can also do this recursively. Because why does Euclid's algorithm work? It works because the GCD of a and b is the same thing as the GCD of b, a% b. And if you do the modular arithmetic, you can convince yourself that this is true. But b is smaller than a, and a% b is smaller than b, so both of these numbers here are smaller than the original numbers. And if you do this enough times, eventually this second number is going to reach 0, and that's when you're done. And your GCD is just whatever the last value was. So Euclid's algorithm works because this fact is true. And that's a nice recursive definition. That's just screaming out, code me recursively. So the base case GCD of a comma b is b if a% b is 0. So if b divides a, then b is the greatest common divisor. Otherwise, recursively call yourself with these new numbers and return whatever value you get. So you can code it in 1 or 2 lines using recursion, or you can loop, right? This is tail recursion. You recurse at the very end of your method, which means you can turn it into a while loop. So whichever one makes sense to you. All right, arithmetic operations. So all of these methods, add, sub, mul, and div, do the same thing. They look for an undefined, and if the number is not defined, you just return nan. Otherwise, you do whatever you're supposed to do the operation. So for addition, if the denominator is 0 or the other number's denominator is 0, just return an undefined number, which I'm using 1 over 0 for. Otherwise, take the second number's numerator times our denominator, add our denominator times the second number's numerator, or the other way around, and then divide by the product of the numerators. And that's the numerator and denominator of the result. Make a new fraction right here and return whatever you got back. And sub's exactly the same, except you subtract. And multiply is easier. Just multiply the numerators and the denominators. And then divide, just do that in the reverse order. And if this bottom part turns out to be 0, my new fraction method will set this thing up to be undefined. It will set the numerator and denominator accordingly. So if you believe your constructor, if you believe it's doing the right thing, you don't have to think too hard when you're doing something like this. Like, wait a minute, what if that second argument is 0? Because you know your fraction constructor is going to do the right thing, right? And that's a mentality you want to stick with throughout all of this object-oriented work. Anytime that you have a method, a constructor, a field, something, if you really believe that it behaves a certain way, right, you can use that and you can count on it. And if it doesn't behave that way, you can go and you can change the code and make sure it does behave that way. And once you've developed it and tested it and confirmed that it's doing exactly the right thing, you never have to think about it again, right? So my new fraction is going to make a fraction. What if it's 0? What if that's negative? What if they have some factor in common? Don't have to think about it because I know fraction's going to handle that in its constructor. All right, 2 double, we're just trying to turn our fraction into a plain old Java double floating point. So again, special case, see if it's undefined. If it is, return this magic double.nan. Otherwise, return numerator divided by the denominator. Do the division. You have to cast one of these things to a double though, otherwise it's an integer divide. And 1 divided by 3 would come out with 0. So by casting the numerator to a double, it forces both of these to be doubles when it divides. You can cast them both if you like. And that's pretty much the whole class. All right, so other questions on PA1, GCD or otherwise? All right, how about PA2? Yeah.
Well, I know what my question is, but I guess
Yeah, we can talk about it.
that's a bigger out. I'm at the stage where I'm trying to make a list within a list.
Okay.
Just making the integer list in my node for word list.
Okay.
But I'm somehow failing to initialize it properly, or I can't seem to add numbers to that list.
So you've got a word list. And you said you call these nodes word nodes?
Yes.
Okay. And what are the fields in a word node? In your word node?
In the word node I'm trying to construct, I have an int data. I have a location node called data node, and I have a word node next.
Okay.
In theory,
Right.
hopefully, because I haven't implemented it.
All right, so we have an integer data. We have a pointer to another word node. And then this thing down here, data node, you said is a location node? It's supposed to be a location node? Okay, and so you have a location list?
Yes.
And these are the location nodes, right?
Supposedly.
Okay.
I haven't seemed to be able to compile that successfully enough it works.
All right, so let's say that this node is called temp. So to start this list off, the following would be legal. Temp dot data node equals new location node. So we know the temp.data node has to be some object of type location node. And this is the syntax for constructing a new location node. And so this would basically plug a little location node into this lower block of your word node. But consider this. What if instead of being a loc node, you actually made this thing an entire location list? And now you could say temp.data node equals new location list. Call the constructor for this entire linked list. And now you've got a linked list of linked lists, even if that second linked list is null. But once you do this, any methods you have in the location list you can access by saying data node dot and the name of the method that's in this class. So now if you have this add to end method that I suggested, you could say something like temp, that's this node, dot data node, which is this location list, dot add to end, and pass it some integer. And that one statement would say, okay, let's make a new node, and let's put the integer I in here, and let's make this null, and let's find the last node and point to it. And again, this is what you want to be sort of heading towards, is things like this, where I'm developing my word list class. I don't want to be thinking about lists of integers. I don't want to be writing statements in my word list class like, well, temp is not equal to null, temp equals temp.next, blah, 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 right? I want to be dealing with my word list up here. Since I have an integer list as part of this node, right, I don't want to rewriting code in my word list to deal with that. I want code to deal with that to be part of the location list. So we bundle those methods inside the location list class. And then we just call them by saying, you know, here's the name of a location list, here's the method I want to call. So that's encapsulation, right? That's taking the code and putting it where it belongs. Code that manipulates a location list is part of the location list. Code that manipulates a word list is part of the word list class. And when you get that separation, you can tell, you can feel it, right? And there's no way to sort of describe how to get that feeling. But when it happens, you'll know it. Does that help at all?
Maybe.
But you should still come to office,
Yes.
because then we can go through specific code.
Class.
I don't have hours today, but I have hours tomorrow starting at 9 o'clock. Is tomorrow Tuesday? Yes. Starting at 9 o'clock. Or Wednesday starting at 8.
Okay, I'll plan to be there around 9.
Okay, awesome. All right, anything else on PA2?
Do we still use null the same way in Java as we do in C?
Null is probably. Null is a null pointer basically, but we don't talk about pointers. But we can use null, for example, if you're making this linked list, and each of these lower parts of a node points to the next node, we can put in the special value null and interpret that as saying it doesn't actually refer to another node, it's the end of the list. And almost anything can take on the value null. So it's always available, but we use it as basically a flag.
Anything can use the value null because were you saying that for Java, pretty much everything you're working with in some way, shape, or form is a reference?
Yeah, everything is an object except for primitives, lowercase int and double and stuff. And null is just treated as a special thing that any object can be set equal to, pretty much. So, I mean, there's your main program again for PA2, right? And it's 3 lines. It's just calling methods inside other classes. It's constructing and then calling a pair of methods. And I did finally run this on War and Peace. And so these are all the references for the word which gets referenced quite a bit.
That's,
As opposed to which is only referenced once.
that's a lot of...
It is. It's not as bad as the though. So we can search for the, and it brings up anything with the word the in it. But if we search for the at the beginning of a line followed by a colon, that brings up exactly one thing, which is all the references for the word the.
Did you time how long it took?
No, it was about 10 minutes, I think.
That's not too bad.
Yeah. So how can we tell how many references there are for the, besides counting all of these?
Word count?
There you go.
Yeah.
Type that into word count. 234,000 references.
I don't think I'm going to do War and Peace as my test.
No, it's a good one at the end though, just to like convince yourself that it works. And also something to think about. War and Peace was 3.2 meg. WP.out, that file with all the references, is 4 meg. Ignoring punctuation and uppercase, lowercase, you can reproduce all of War and Peace from that location count, from that index. Right? How? You come through here and you make an array and you put the word above at all of these locations in the array. And you put the word above board at this location, and
That's a very big array.
Abramovna at this location, and abroad at these, and so on and so forth. And when you're done, you print out your array in order, and there's War and Peace. So this is a translation from straight text into a different representation. It's slightly larger, but if we were to store these numbers more efficiently, we'd probably have a smaller version of War and Peace, something that took less space storage. So it might be a lossless compression technique, other than punctuations. So it's like a dual to, it's the KVL to War and Peace's KCL. How about that? All right. So let's talk about statics. And I mentioned last week to avoid using the word static except in public static void main. But I want to go through it today and tell you where you could use it. And you don't need to, but this is something potentially useful. So let's go back to our fraction class. And remember, I had this method called GCD that takes two integers and returns the greatest common divisor. And that's possibly a useful thing to do. If you're doing 215 homework, right, and you had this, you wouldn't have to work. You just throw your numbers in and get the GCD, right? Don't do that. And it doesn't have to have anything to do with fractions. If I just have two numbers and I want to know the greatest common divisor, I might not be thinking about fractions or rationals or anything like that, or Java. I just want to find the GCD, and I know there's a method in here for doing GCD. So I'm going to try to use this method. So I'll do something like this. Let's make a new main class. So there's our main method.
GDC?
Yeah, you know what I mean, right?
Yes.
All right. So I'd like to do this. I'd like to use the GCD method. But where is that GCD method? It's inside the fraction class. Right? So in order to run it, I need the name of a fraction. I need an object of type fraction so that I can say use the GCD method from that object's class. So I'm forced to do something like this. Fraction temp equals new fraction. And I'm just going to make it a fraction 1 over 1 because I don't really care about fractions. But once I have this thing, I can do the following. I can say, okay, give me the GCD method inside temp.
You misspelled fraction.
Yeah, I do that. How's that? All right, so I run that and it tells me my GCD is equal to 13. And that's good. But this is kind of weird. I don't care about the fraction 1 over 1. I had to construct a fraction just so I got this object temp so I could say temp.gcd. And that's kind of goofy. So there's a mechanism to be able to run a method inside a class without having an instance of that class. So like this is what's called an instance method. So like temp is an instance of fraction, and then we say temp.gcd. That's an instance method. We're running it from an instance a constructed version of that object. The alternative is what we call a static or a class method. So if we go back in fraction.java, I'm going to call this thing static int GCD. And what that means is that I can do the following. Instead of creating an object and then using that to access this, I can actually just use the name of the class. So fraction is not an object. It's not actually a fraction, it's just the name of the class. But because I define GCD to be static, it's going to go into that class, find the definition of GCD, and then run that code. And so that works without having to create a goofy random object. Now if I take that static keyword out, it's going to complain and say it's expecting a static method, and it didn't find one. So this is sort of a bifurcation of types of methods. So this is a static method or a class method, as opposed to one that's constructed from an instance. So what is the deal with this static keyword on public static void main that we've been typing from day one? Why do we have the keyword static up there? So if this is public static void main, how would I access this method from somewhere if I wanted to run it?
You will call the method itself, which is main or class, M2.
Yeah, so I would call the method main. It's static, so it's a class method, which means I need the name of the class. So I would say something like M2 dot main, and then I'd pass some arguments to it. This is how the Java command runs your program. When I say Java M2, like right here, the JVM says, okay, let's look for a class method inside M2 named main. And it basically, there's a little JVM in there, and it looks for this method called m2.main. And if it finds it, it starts executing that code. That's how your main program kicks off. All right, does that make some sense? Again, you don't need to use static anywhere except public static void main. But if you find yourself creating some method that you want to use in general, and it's not really something that depends on a particular instance of an object, right, that's a place where you can make it static. I did Java for years without knowing about static. And I did the goofy thing. Every time I wanted to run this piece of code called compile, I made an object of my certain type, and then I said object name dot compile. And I was like, wow, that's really, really cheesy. I wish there was a better way to do that. And it was years before I discovered static. So you don't need to do it, but it makes things cleaner and more logical. So if you look at the integer class, it's got a bunch of methods. One of the methods it has is parseInt. So parseInt takes a string and it returns an integer. This is like scanf with a %d. This is how we convert a string into an integer. And this is declared to be a static method. Why? Because this is something that involves a string and some kind of return int value. It has nothing to do with an object of type integer, uppercase I. So we want to be able to access this thing which is part of the integer class, and we can do it with something like this. All right, integer.parseInt. And this is just like the example I keep going back to, math.squareRoot. That's a static method inside the math class. And this is what you did in PA1 when you returned this. This is a static field, a static variable inside the double class. So we've been using these already. Math.abs, that's a static method in the math class. Character.isLetter for PA2, that's a static method inside the character class. So suppose you want to run a Java class and you want to pass it an integer and treat it actually as an integer. So how do we get to an argument that you used when you said Java program name? How do we find the first argument that you put on the command line? Can we find the first argument? I'm going to say Java fun, ha ha ha. And somewhere inside here, I want to get a hold of that string, ha ha ha. Yeah, args bracket 0. That's the first argument. That's why we put string bracket bracket args every time we write main. So if I were to do something like integer I equals integer dot parse int args bracket 0. And then print out the value of I, that should give us our conversion from a string to an integer. All right, so I equals 101. If I say Java fun ha ha, I get an exception because it can't convert ha ha to an integer. Does anybody here know the 3n plus 1 thing? We talked about this briefly in 215. Somebody brought it up actually. So start with a number n. If it's even, divided by 2. If it's odd, multiply by 3 and add 1. And keep going. And you can do this by hand, but it's more fun to do by computer. And your goal is to do this until your integer comes down to 1. So while I is not equal to 1, so while I is not 1, we'll set I equal to I over 2 if it's even. Otherwise, we'll set I equal to 3 times I plus 1. And we'll print these out. And then we'll print a new line. So if we give it the number 2, it just goes straight down to 1. If we give it the number 3, it goes through this. Number 4 is a short path, and number 5 is pretty short. Number 7 is pretty big. And depending on the number you put in, sometimes you get very long things. There's 10,004, and that's a very short one. And this is a fascinating function. And it's an open question whether this always gets you down to 1 or it gets to some number that just loops forever, other than 1. And it's unsolved. And it's like really, really easy to sort of grasp what the question is. Right? Start with a number, divide by 2 as long as it's even, otherwise multiply by 3 and add 1. Does it ever bring you down to 1? And up to some ridiculous amount, it always seems to bring you down to 1, but nobody's proven that that always happens. But pretty easy function to like spin out in Java if you can parse ints and play around with. All right, so tomorrow I want to talk about exceptions. How do we deal with this case where you put in something that's not an integer and you try to convert it? I want to talk about something called class extensions, which is how we can make new classes from old classes. And then we're going to start playing with IntelliJ. And we're going to start talking about some GUIs and some graphical stuff. All right, so we'll pick up from there tomorrow. All right, have a good rest of the day. I'll see you tomorrow.